Alright everyone, this is my first video using this software. So let's dive into the problems. 1 says which number is not a rational number, and 2 says which Venn diagram correctly shows the relationships between the subsets of numbers. Well, there's another typo there. But before we do both these problems, we need to first review what rational and irrational numbers are. So irrational numbers are numbers that don't make sense. Irrational literally means it's not rational. It doesn't make sense. In a number sense, what that means is a number that goes on forever with no pattern. So I'm going to write that here. Oops. Draw a number that goes on forever. Forever with no pattern. So some examples. Pi is an example. Another example is square root of 2. The square root of 2 is equal to 1.4142135. It goes on forever. Another example is E, which is 2.71. It goes on further. It's similar to pi. Another example is square root of 20, and the square root of 20 is 4.4721. So those are some examples of some irrational numbers. Now, rational numbers, they're numbers that make sense. The definition is any number that can be expressed, which just means written, expressed as a fraction. So what this really means, is any positive, negative, decimal, fraction, or integer, a number without any decimals or fractions. So some examples are negative or 0.35, negative 3 over 10. You can basically just think of any number here. 4, 0, negative 3. Now here's, I think, where most people got tripped up. Here's some more examples. Negative 16 is rational, because what is negative 16? It's 4. It's a perfect square. I'm going to draw that here. It's a perfect square. What I mean by a perfect square is a number, two numbers when multiplied together give me this here. So 4 squared would give me 16. So the square root of 16 is 4. Another example of a rational number is square root of 5. Okay. So now that we've covered the difference between rational and irrational, I think that should help you with problem 1. And if I give you some more pointers, which number sorry.
Somebody was looking for you, sir.
Okay.
I think it was Mr. Ramirez.
Oh, I found him. Yep. Thank you. Which number, oops, sorry. Which number goes on forever? So, and with no pattern. With no pattern. That's also key. With no pattern. So I know that negative 26.25 stops, and it actually can be expressed as a fraction. It'd be negative 26 and 1/4. Negative 10, well, that's just a negative integer, so that's rational. Now 14 over 3, this can be expressed as a fraction. It does make sense. Now here, square root of 7, this is not a perfect square. So if we calculate what the square root of 7 is, square root of 7 is going to be 457, and it goes on forever. It's not a perfect square, so that will indicate which answer is correct for problem 1. Okay, now let's go ahead and do problem 2. I'm going to erase some of this stuff here. Okay. Now, within rational numbers, there are more specific types of numbers. So it goes rational, and more specific, a smaller category, are integers. The definition of integers: no decimals, no fractions. No fractions can be positive or negative. Can be positive or negative. Now, the next is whole numbers. Slightly more specific, whole numbers. Same thing here as these two, no decimals, no fractions, but the only difference is it is only positive. So, no decimals, no fractions, and only positive. Okay? And the last, which is just a ridiculous, I don't know why we have this in math, but we do, so it's good, it's worth noting. It is natural numbers, which is the most specific. It's supposed to be an arrow. I'm sorry, let me rewrite that. Okay. Natural numbers. And the only difference between whole numbers and natural numbers is that natural numbers cannot be 0. So all of these three things here, let's see if I can copy this. Copy. Paste. Oh, perfect. Okay. No decimals, no fractions, only positive, but the only difference is 0 is not natural. Is not a natural number. Natural. I'm running out of room. Oops. I'll erase that. Is not. Oops, that's erased. Natural. All right. So, if we zoom out, well, if I zoom up here, rational, whole, rational, and then to integers, then to whole numbers, then to natural numbers. That should help you with problem 2. Thank you very much, and happy math solving.